today we're going to talk about symbols in geometry diagrams. And there are basically 4 types that we're going to look at within the diagrams. And then there's kind of corresponding ones that are not used in the diagrams. So let's say we have a diagram like this. To make this look realistic. And then there's a line here and a line there. What does this mean? A line going across this and a line going across this. Well, what this means is that this line segment here is congruent, which means equal to this line segment here.
Isn't that like
and the way we would write that, the way we would write that is, AB, line segment AB, is congruent to line segment BB. So one line here and one line here means that this line segment, here's the symbol for congruent. It's congruent to this other. What does congruent mean?
Same.
Equal or the same. Okay, and then this can get slightly more complicated. Let's say we had a rectangle. I might say that this side is the same as this side. And then I want to say that this side is the same as this side also.
So that's you do the 2 lines.
Right, but it's not equal to this side. So I'm going to do 2 little lines next to each other. And what that shows me is this side is congruent to this side because they both have 2 small lines. And this side is congruent to this side because they both have 1 small line. And sometimes you'll even see 3 lines, right? So 3 lines and 3 lines would mean the 2 segments that have 3 lines are congruent to each other. Alright. So that's how we show congruent lines or line segments. Well, lines are never congruent. So that's how we show congruent line segments. How about angles? Angles is sort of a similar thing. So let's say I had this big kite. This is not really going to be believable, but let's say this angle is the same as this angle in my kite. I use one little arc to designate that. So now let's label this diagram. Say that's A, B, C, D. The way I would write this out is angle A, B, C is congruent to angle
A, B, C.
let's say that's right. Okay. Let me just check. I can't remember if I need to write the little m for measure on there. No. Okay. So just like that. The angle ABC is congruent to angle ADC. And remember that the vertex of an angle is always going to be the middle letter. Okay, when we're writing these out. And just like we did for the line segments, I could use two little curves to show a second set of congruent angles. Right? So this would now say angle DAB is congruent to angle DCB. Those are equal because they each have two of those little marks. And if I put 3, the two angles that had 3 would be equal. Questions on that? All right. On the second set of symbols, say we had this diagram here. You guys already know this little symbol means perpendicular to. So let's make that A, we'll make that B, let's make this a line. And then we'll make this point be C, D, and let's make this E and make this one a line. So perpendicular can be expressed like this. I can say line A, B is perpendicular to, it's kind of like an upside down T. In this case, C, D.
Wait. Oh, never mind.
Yeah, I could have probably left off this A and just done these 2 points, but whatever. And then
How do you say parallel?
parallel, yeah. Parallel is like this. Let me make sure I'm drawing this exactly correctly. So we have these little triangles. And this is sort of like congruent in that if I have a second set of parallel lines, I could use 2 little arrows to show this set is also parallel.
But what if they're lines that go on forever? Couldn't you just use all the same ones because they're all parallel and going on forever?
Well, these are parallel
no.
to each other, and then these are parallel to each other. But this is not parallel to this one, so I use 1 triangle to show this set and 2 triangles to show that set. Does that make sense? And then if I wanted to write this out, I could say that line AB is parallel to B. So it kind of looks like 2 L's, like in parallel. We have
Or
2
two
L's.
parallel lines.
Or 2 parallel lines, yeah, like kind of like that one is 2 perpendicular lines. Now it's important to realize that in a diagram like this, we can't assume anything. So like I can't assume that these 2 are perpendicular unless they tell me. But where we're moving with this, kind of the next step, is that based on what we know about a diagram, we might be able to prove that something else is true. And that's what a lot of geometry is about, is showing that if this is true, then this also must be true. So they'll do something like, they'll give you this angle here, and then they'll ask you to find this angle over here or something like that, based on all these theorems and postulates that you have for angle relationships and stuff like that. So as you do your homework tonight, there's not going to be any finding angles, but I do want to have a discussion tomorrow about what could we show on these diagrams. If you knew this and this and this, is there anything else that you could actually prove, or that you do know based on the postulates and theorems we've developed so far? So I want you to be looking for those patterns already. Even though I'm not asking you to write anything down, just be thinking as you label these diagrams. Well, if this is parallel and this is perpendicular, wouldn't this also have to be perpendicular to this? Or, oh yeah, this is a vertical angle, so if this adds up to 60, then this other vertical angle must also be 60. Look for those things and start to recognize them in the diagram. It's great practice. All right, any questions on these symbols? So just to review, why can't I turn